Okay. I will record this. So this is sine, so where the x starts, the middle line is it gonna start here? But its amplitude is 3, so this here, we move up 3. But then this changes it to where there are this line here, this like curved line, there are gonna be 2 of these in between 2 pi, so we have to shrink that down. So now there are 2 of them between 2 pi. If this was like half instead of 2, we would extend it out all the way, or oh man, oh, this is okay. If this was like half, then we would like do this. We would change it to 4 pi instead, because we only have half of it is going to 2 pi. But since this is 2x, we want 2 lines to happen before 2 pi happens. So we have 1, 2. Then we check the answer, and we got it. Then for this one, this is another sine. This is 3 sine, so we're gonna set the amplitude of 3. And then this is 3x. So what this wants is that we want three of these little swoopy things to happen before 2 pi happens. So we're gonna move it. This is pi, but we want to move it 1 more. There. So now we have 1, 2, 3. Get it? There you go. So now this is cos, and in my opinion, he has this set up awfully. So what I do is I'm gonna move this over right first, so that this thing here is over. Ooh, hopefully I've been recording the screen and not off to the side. That's my bad if I have been. And then this is 2 cos, so we're gonna set the amplitude to 2, and then we're gonna move it down 3. Oh man, hold up. Okay. So then now we're gonna move this down 3. There. And then we check, and we got it. Okay, so for this one, this is 2 sine. So we're gonna set it to amplitude 2 first, and then we're gonna move it down 1/2. And that's essentially all you have to do. And you got it. Ugh. So this one is now 2 sine. So we're gonna move up to get it to the amplitude 2, and then we're gonna move it left pi 6th, because this plus means it moves left, which is counterintuitive, but it works. And that's up, but then we have to move it up 4, so then it goes there. Check that, and there you go. And this is another 2 sine one, so set the amplitude to 2, then move this left pi 4ths. But then you want to move it down 2 as well. There. And that's all you gotta do.
Michael, what are you recording?
Video for Natalie. Okay. And there you go. Oh, whoops. Here is 3 cos, so set amplitude to 3. So we get this minus 3 here, and then we're gonna move it left pi 6th to there, and then we're gonna move it down 4. There. Because this pi 6th here moves it left, then that moves it down 4. What? Oh, he has the graph set up weird. Okay, so I forgot for cos, you want to set it up to where this thing is here first, and then move it over pi 6th. So right there, that should be good. There we go. Okay, so here's another cos, and we're gonna set it up like how a cosine should. So we're gonna have that point there, and do to amplitude 2, and then we're gonna move it. Shoot, we're gonna move it right pi thirds. So we're thinking here, so we're gonna move that over until it gets to this spot here. So there. Now that's at pi thirds there. Then we're gonna move this down 3. Oh goodness, okay. So this graph, this is a cos graph. Remember, we're looking at this point here. So what the period is, so we're gonna move this left pi thirds, and that means that this moves also pi thirds over, so now it's gonna be over 2 pi. So the period here is just 2 pi, so that means it hasn't changed. And the amplitude, so we see here that this is at 2.25, and then this is at 1.75, so this has moved up. The amplitude, or let's do the vertical shift first. What has happened here is that this has moved up 0.25 because this point and this point aren't the same. So if we minus 2.5 here and then minus 2.5 here, this will be at -2, and then this will be at 2, which then gets you 0.25. So now with that, we can do the amplitude. So if we minus 2.5 here, we get 2. Then we get -2. So the amplitude is 2 here. And phase shift is, since this is cos, this is supposed to be here originally. So now it's here. So it has moved pi up. Pi. Oh, wait. Plus pi thirds. Now enter the equation. So with all this information, we're going to do, so the amplitude, or you do the y equals first, obviously. You do amplitude first, which is 2, then cos. And since the period didn't change, we just do x. Oh, right, not just x. And then we do, because it moved right pi thirds, we do minus. It moved right pi thirds, so that'd be minus pi that, and then we plus 0.25, which should give the same thing. Yep, there we go. Then, so now this is sine. So instead of looking at this point, we're gonna look at this one here. So I can already tell that this has not moved left or right at all. So for the phase shift, we're just automatically gonna put none. Automatically put none for the phase shift, because all this has done is move down 3 for the vertical shift. Now, if this was like cos or something, this would have moved down 3, but then also over pi 8s. But since it's sine, it's just only moved down 3. Then the period here, so, ooh, okay, period is, so to solve period, so this is at pi halves, and then we'd have another one at pi, and another one at whatever it is, 3 pi halves, and another one at 2 pi. So that's 4 of these swoopy lines until we get to 2 pi. which is how we determine the period. Then the amplitude, we start here, and then we go up 2, then we start here again, and then we go down 2. So amplitude 2. Hopefully I have been pointing the camera at the right spot. Yeah, I have, essentially. And then for the equation here, this should be pretty simple. So we do y equals 2, because of the amplitude, sine. And now, what differs from the last equation is that we have this 4 here in the period. So now we're going to do 4x. And then that's it for that. And then we do minus 3. What? Oh, wait, the period is pi halves. Not 4. Or pi half. Because the period is from here to this point. That's what the period is. Let me check again, and yep. And that's it.